Now here the question is, if S1, S2, S3, Sn are sum of infinite geometric series whose first terms are 1, 3, 5, 2n minus 1 and common ratios are 2 by 3, 2 by 5 and 2 upon 2n plus 1, then find the sum of the series up to infinite terms. Now what we'll do is, we'll take this general series, suppose Sk. Now for this Sk, first term Ak, it is given by 2k minus 1 and its common ratio will be 2 upon 2k plus 1. Now since this is sum of an infinite GP, Sk is Ak upon 1 minus R. So it is 2k minus 1 upon 1 minus 2 upon 2k plus 1. Now here will be 2k minus 1, 2k plus 1 and will be 2k minus 1. So this Sk is nothing but it is 2k plus 1. So if we look at sum of the series S, it is 1 upon S1, S2, S3 plus 1 upon S2, S3, S4, S3, S4, S5 and it continues up to infinite. Now S1 is 3, so it is 3 into 5 into 7. This is 5 into 7 into 9. 7 into 9 into 11. Now here the terms, they are in AP and the difference between the first and last term in each expression is 4. So this difference, it is 4. So what we'll do is, we'll multiply with 4 and we'll divide with 4. Now we can write this as 7 minus 3 and this is 3 into 5 into 7. This is 9 minus 5. 5 into 7 into 9. 11 minus 7. 7 into 9 into 11. This is 1 by 4. Now here we have to split it. This 7 is going to cancel. So it will be 1 upon 3 into 5 minus 1 upon 5 into 7 plus here 9 will cancel. So it will be 1 upon 5 into 7 minus 1 upon 7 into 9 plus 1 upon 7 into 9 and it goes on. All these successive terms, they'll cancel. So answer to this series is 1 upon 3 into 4 into 5, which is 1 by 60. So answer to this question is 1 by 60 and that's your option B. Now here the question is, if A1, A2, A3, A2n plus 1 are in AP, then we need to simplify this series. Now we know that if A1, A2, A2n, A2n plus 1, they are in AP, then in that case, A1 plus A2n plus 1 by 2 is equal to A2 plus A2n by 2. That is, arithmetic mean of terms equidistant from beginning and end, they are all equal, and since in this AP there are odd number of terms, it will be equal to its middle term, and its middle term will be when the value of R is 2n plus 1 plus 1 by 2. So this is equal to A n plus 1. So all these denominator in this expression, they reduce to 2a n plus 1. So we can write this series as 1 upon 2a n plus 1 and this is a2n plus 1 minus a1, a2n minus a2, an plus 2 minus an. Now this is 1 upon 2 an plus 1. Now a2n plus 1 is a1 plus 2n into d minus a1. This a1 and a1 will cancel. Now a2n is A plus 2n minus 1d minus A2 is A1 minus d. Now here A1 will cancel. So we'll get this as 2n minus 2d. I'll continue. And here it will be 2d. Now we can write this as 1 upon 2 an plus 1. This is 2n. This is 2 n minus 1. And goes all the way up to 2 into this common difference d. Now we can cancel this 2. Now this is nothing but sum of first n natural numbers. So it is n plus 1 by 2 an plus 1 into d, where d is common difference. So we can write this as n plus 1 by 2 an plus 1 into a2 minus a1. And that's your option A. Now here the question is, if A, B, C, D are non-zero real numbers such that a square plus b square plus c square into b square plus c square plus d square, it is less than or equal to ab plus bc plus cd whole square, then abcd Rn. Now basically, if we look at Cauchy-Schwarz inequality, we know that a square plus b square plus c square into b square plus c square plus d square, it is always greater than or equal to ab plus bc plus cd whole square. And this is nothing but it is a dot product result, which is a dot b is always less than or equal to mod of a into mod of b. So this right hand side, it is dot product, and these terms, they are two vectors a and b. Now in this question we are given this other result. Now this other result, it can only be true if and only if there is an equality sign. So that means a square plus b square plus c square into b square plus c square plus d square, it must be equal to ab plus bc plus cd. Now Cauchy-Schwarz inequality says this result is true when a upon b equals b upon c equals c upon d. That means a, b, c, d are in GP. And if we look at this vector product, then we know that a dot b is equal to mod of a into mod of b if a and b are collinear. And if a and b are collinear, then a upon b must be equal to b upon c must be equal to c upon d. That means a, b, c, d, they are in GP. So we can solve this question either using Cauchy-Schwarz inequality or using dot product, and that's your option B. Now here the questions, we are given that 4a square plus 9b square plus 16c square equals to 3ab plus 6bc plus 4ca. Now we can write this as 2a square plus 3b square plus 4c square and minus this is 2a into 3b minus 3b into 4c and minus 4c into 2a, and it is equal to 0. Now this is our known result. We are given that a square plus b square plus c square minus ab minus bc minus c is 0. That means a must be equal to b must be equal to c. So from here we can write 2a must be equal to 3b and must be equal to 4c, and it is equal to k. So we get 2 equals k by a, 3 equals k by b, and 4 equals k by c. Now 2, 3, 4, they are in AP. That means k by a, k by b, and k by c, they are in AP. 1 upon a, 1 upon b, 1 upon c are in AP. That means ABC, they are in HP. That means the correct option is this option C. Now here the question is, we are given that x square plus 9y square plus 25z square, and it is equal to 15yz plus 5xz plus 3xy. Now this is x square plus 3y square plus 5z square minus 3y into 5z minus x into 5z minus x into 3y equals to 0, which again is a square plus b square plus c square minus ab minus bc minus ca. So again we'll get a equals b equals c. So from here we'll get x equals 3y equals 5z, and suppose it is equal to k. So 1 equals k by x, 3 equals k by y, and 5 equals k by z. Now 1, 3, 5, they are in AP. So k upon x, k upon y, k upon z, they are in AP. We can cancel this k. Then clearly x by z, they are in HP. So it's a similar question. So answer to this question is this option C. Now here the question is, if A, B, C, D and P are distinct real numbers such that a square plus b square plus c square into p square minus 2ab plus bc plus cd into p plus b square plus c square plus d square is less than or equal to 0, then a, b, c, d are n. Now what we'll do is, we'll take terms of p square, p and this b square together. So we can write a square p square minus 2abp plus b square. In the same way, we can write this second term as b square p square. We'll take second term from this second expression, 2bcp plus c square and plus c square p square minus 2 cdp plus d square is less than or equal to 0. Now these are nothing but perfect squares. This is AP minus B whole square plus BP minus C whole square plus CP minus D whole square, it is equal to 0. Now sum of squares, it is 0 if and only if each of these expressions, they are 0. So from here we get P as B by A, which is also equal to C by B, which is also equal to D by C. That means A, B, C, D, they are in GP. That means the correct option is this option B. Now in sequence and series, we have this one shortcut which is very handy when it comes to problems involving terms common to the two or more given arithmetic progressions. So we'll be given two APs. Suppose we have this first AP which is characterized by A1 plus D1 and so on. And we have this second AP which is A2 plus D2, A2 plus 2D2. Then the terms which are common to both the APs, they'll also form an AP whose common difference is given by LCM of D1, D2. So the terms which are common to both the APs, they'll also form an AP, and that common difference will be LCM of common difference of the two given APs. And by observation or by using initial few values, we can calculate this A, which is first common term. And once we have first common term and common difference, then we can solve whatever is desired in the given question. So let us take one example. Now here the question is the 10th common term between the two series. So we are given two series. First series is 3 plus 7 plus 11. It is an AP, and in this AP, common difference is 4. And then we have this second AP, which is 1, 6, 11. So it is also an AP, and its common difference is given by 5. Now the terms which are common to both the series, they'll form an AP whose common difference will be given by LCM of D1, D2. So it will be LCM of 5 and 4, and LCM of 5 and 4 is 20. And from observation, we know that its first common term is 11. So we have first common term, and we also have its common difference. We need 10th common term. So the 10th common term between the two series will be 10th term of this AP, which is A plus n minus 1 into D. So this is 180 plus 11, and that will be 191, and that's your option A. Let us take another example. And this question, it says the largest term common to these two sequences, both they are an AP containing 100 terms. So this first AP, it is 1, 11, 21, 31 up to 100 terms. So that's your first AP. And then our second AP is 31, 36, 41, 46 up to 100 terms. Now terms common to both the series, 31, 41, they'll also form an AP whose common difference is LCM of common difference of the two APs. Now common difference of first AP is 10, and common difference of second AP is 5. So we need to find LCM of 10 and 5. So it will be 10. Here in this case, value of D is 10, and again just by observation we know that first common term is 31. So this AP of common terms will have first term as 31 and common difference as 10. Now its general term Tn will be given by A plus n minus 1 into D. So it will be 31 plus n minus 1 into 10. Now we need largest term common to the sequence. Now largest term common to the sequence will be less than or equal to minimum of last term of the two sequences. Now basically minimum of the two sequences will be in this second series. So this Tn, it should be less than or equal to last term of this second sequence, and which is 31 plus 100 minus 1 into D, which is 5. So this 31 will cancel. So we'll get n minus 1 into 10 will be less than equal to 99 into 5, or this n will be less than or equal to 50.5. So the highest value of n in this case will be 50. So the largest term which is common to both the series will be 31 plus 50 minus 1 into D. So this is 31 plus 490, which is 521, and that's your option D. Now let us take another example, and this question was asked in JEE Advanced 2019, and the question was, we are given 3 APs. So we have this first AP whose first term is 1 and common difference 3. Then we have this second AP whose first term is 2, common difference 5, and then we are given this third AP whose first term is 3 and common difference is 7. It says we need to find intersection of these 3 APs. Basically we need to find terms which are common to the 3 APs. So terms which are common to all the 3 arithmetic progressions, and we already know that terms which are common to APs will also form an AP, and in this case we need to find the value of A and D, where A is first common term and D is their common difference. Now D is simple. Common difference of the common terms of the 3 series is basically LCM of common difference of 3 APs. So it will be LCM of 3, 5 and 7. Now we know that LCM of 3, 5 and 7 will be 105. So common difference of this AP of common terms will be 105. Now we need to find A, which is first common term. Now what we'll do is, in order to find A, we look at general terms of these 3 APs. Now general term of this first AP, we can write this as 1 plus n minus 1 into 3, or we can simply write this as 1 plus 3p, and since we need common terms, it should be equal to general term of this second AP, which is 2 plus 5q, and it should be equal to general term of this third AP, which is 3 plus 7r. Now what we'll do is, first we'll find terms which are common to these 2 series. Now for these 2 series, we can write q equals 1 plus 7r upon 5. Now what we'll do is, we'll put the value of r and we'll find the smallest value of r, for which this q, it is an integer. If we put r as 1, it is not an integer, but if we put r as 2, we'll get q as 3. Now this is 15 plus 2, 17. So first common term of these 2 APs, it is 17. Now we know that common difference of these 2 series are 5 and 7. So common difference of terms which are common to these 2 series will have common difference, which is LCM of 5 and 7, which is 35. So the terms which are common to these 2 series, they are 17, and then 17 plus 35, 52, 52 plus 35, 87. Now we need that term which is of the form 1 plus 3p. That means from these numbers, we have to find that first number which, when divided by 3, leaves a remainder 1. Now when 17 is divided by 3, it leaves the remainder 2. So 17 is not our common term. If we look at 52, now we know that 17 into 3 is 51 and plus 1. So basically this 52 is 17 into 3 plus 1. So this is our first term which is common to all the 3 APs. So that means value of A is 52. Now we have A and we have D. We need to find the value of A plus D. So A plus D will be 105 plus 52, and it will be simply 157, which is the answer to this question. Today we'll discuss a shortcut which is used in the problems where difference of difference is constant. So you'll find many problems in which you'll be given a series such as A1, A2, A3, A4, A5. Now in this series, if we find their difference, so A2 minus A1 is D1, A3 minus A2 is D2, A4 minus A3 is D3, A5 minus A4 is D4. So this is your difference series. And if we take difference of difference, that is D2 minus D1 as D, D3 minus D2 as D, and D4 minus D3 is D. So in this case, difference of difference is constant. So we'll get many cases in which difference of difference will be constant. Now, in this case, we know that its nth term will be given by a quadratic term. So it will be an square plus bn plus c. Now, first we'll look at its standard way of solving the question, and then we look at the shortcut. Now, in order to find a, b, c, we'll need to find three equations. So what we'll do is we'll put n as 1, and if we put n as 1, we'll get a plus b plus c, and it will be equal to t1, and t1 is nothing but its first term. So it will be this a1. Now, if we put n as 2, we'll get this as 4a plus 2b plus c, and it is t2, and t2 is your second term, which is a2. And if we put n as 3, so we'll get this as 9a plus 3b plus c, and that will be equal to a3. So now we have three equations and three unknowns. We need to find the value of a, b, and c. Now what we'll do is we'll subtract first from second. We'll get 3a plus b equals a2 minus a1, and a2 minus a1 is nothing but d1. In the same way, we can subtract second from third. We get 5a plus b, and that will be equal to a3 minus a2, and that will be equal to d2. Now we have equations in a and b. In order to find this a, we'll subtract this first equation from second. So from here we can write 2a equals d2 minus d1, and d2 minus d1 is nothing but d. Now what is the shortcut here? Shortcut here is once we have this series, we can find their difference and we can find their successive differences. Now this constant difference d, it is nothing but 2a. So we'll simply write this as 2a. Now d1 is nothing but 3a plus b. So we'll write this as 3a plus b. And here this a1 is a plus b plus c. So here this is a plus b plus c. So from here we'll get the value of a, and if we put the value of a here, we'll get the value of b, and from a and b we can get the value of c. Now let us take one example. Say for example we are given this sequence which is 6, 11, 18, 27, 38, 51. We need to find its nth term. Now if we take the difference, 11 minus 6 is 5, 18 minus 11 is 7, 27 minus 18 is 9, 38 minus 27 is 11, and 51 minus 38 is 13. Now if we take the difference, this is 2, this is 2, this is 2, and this is 2, which means difference of difference is constant. Now we'll use the shortcut directly. Now this is 2a, this is 3a plus b, and this is a plus b plus c. Now clearly a is 1, and if we put a as 1 here, we'll get b as 2, and if we put a and b as 1 and 2, then value of c is 3. So nth term of the sequence, it will be simply n square plus 2n plus 3. Let us take another example. We are given the series 6, 13, 22, 33. Now 13 minus 6 is 7, 22 minus 13 is 9, 33 minus 22 is 11. Now again 9 minus 7, 2, 11 minus 9, 2. So we can write 2a as 2. Now this is 3a plus b, it is equal to 7, and a plus b plus c, it is equal to 6. Now clearly a is 1, and if we put a as 1, we'll get b as 4, and if a and b are 1 and 4, value of c is 1. So value of c, it will be 1. So nth term for this series, it will be n square plus 4n plus 1. And that is the answer to this question. Now let us take another question. And here we need to find the sum of the series up to infinite terms. What we'll do is we'll find sum up to n terms. Now in the numerator, we have this series 2, 6, 12, and 20, and so on. We'll write the differences. 6 minus 2, 4. 12 minus 6, 6. 20 minus 12, 8. Now this is 2 and this is 2. Now we can use the shortcut. This is 2a. This is 3a plus b. And this is a plus b plus c. Now clearly a is 1. And if we put a as 1, we get b as 1. And if we put a and b as 1, we get c as 0. So its nth term will be n square plus n. Now in order to solve this question, we have to write general term of the series. It is TR, and it will be in the numerator we'll have r square plus r, In the first term it is 1 cube, second term it is 1 cube plus 2 cube. So it will be 1 cube plus 2 cube up to r cube. Now we can write this as tr equals r into r plus 1, and this is r plus 1 by 2 whole square. As r plus 1 will cancel, so it will be 4 upon r plus 1, which we can also write as tr equals 4, and this is 1 upon r minus 1 upon r plus 1. Now we need to find sum of n terms. So Sn, it will be 4. Now we put t as 1, it will be 1 upon 1 minus 1 upon 2. If we put t as 2, it will be 1 upon 2 minus 1 upon 3. 1 upon 3 minus 1 upon 4. I will continue up to 1 upon n minus 1 upon n plus 1. Now here 1 by 2, 1 by 3 will cancel. So what we'll get is Sn equals 4 into 1 minus 1 upon n plus 1, which is 4n upon n plus 1. Now we need to find sum up to infinite. Now S infinity is limit n tends to infinite, Sn. Now here highest power of n is 1. So its answer is 4 upon 1, which is simply 4. And that is the answer to this question. Now the question is, the largest term common to the sequence is 1, 11, 21, 31 up to 100 terms and 31, 36, 41, 46 up to 100 terms is. Now there are many ways to solve this question. We'll solve this question in two ways. Now first method is, we know that any general term for this first series can be written as 1 plus n minus 1 into d. So it will be 1 plus n minus 1 into 10, and we need common terms. So it will be equal to general term of this second series, which is 31 plus n minus 1 into 5. Now this is 10n minus 9, and this is 5m plus 26. I will take this 9 here, so it will be this 10n, that is 5m plus 35. We can cancel 5, so we can write 2n, and it will be equal to m plus 7. So this n will be equal to m plus 7 by 2. So the terms which are common to this series, they must have this criterion that this n must be equal to m plus 7. Now since m and n, they are positive integers, that means this m, it must be an odd number. Now we need largest term common to both the sequences. Now we need largest term. So highest odd value of m will be 99. In that case, value of n will be 99 plus 7, 106 divided by 2, so it will be 53. So the largest term which is common to both the series will be 1 plus n minus 1 into 10. For it, we will put n is 53, so it will be 53 minus 1, 520, so it will be 521. We could have done it with m also. If we put m is 99 here, we can write this as 31 plus 98 into 5. Now this is 490 plus 31, which again is 521. And that is the option D, none of these. Now, second method of solving this question is, we have this theory that if we have two APs whose common differences are D1 and D2, then terms common to both the APs, there will also be an AP whose common difference will be LCM of common differences of these two series. So in this case, the terms which are common, they'll form an AP, and common difference of that AP will be LCM of, now here common difference is 10, and for the second one common difference is 5. So the value of D, which is an AP, will be 10. Now the first common term in both the sequences 31. So the terms which are common to both the series will form an AP with first term 31 and common difference of 10. Now if we write its general term Tn will be 31 plus n minus 1 into 10, and this Tn, it must be less than or equal to minimum of highest term of both the series. Now in this, last term of the second series will be less than last term of this first series. So last term of this second series is 31 plus 99 into 5, and it will be 526. So it should be less than 526. Now if we simplify this, we can write n is less than or equal to 526 minus 31 divided by 10 plus 1. So n should be less than or equal to 50.5. That means highest value of n will be 50. And if we put n as 50, we'll get this term as 31 plus 49 into 10, 490 plus 31, and that will be 521. So this is second method of solving the same question. Now here the question is, in the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, where n consecutive terms have the value n, then 1/50th term is. Now suppose this is series of n minus 1, it ends here, and then we have series of n, and then we'll have series of n plus 1. And suppose 1/50th term, it lies in this series of n. So we need to find the value of n. Now here we have one term, here we have two terms, here we have three terms, and here we'll have n minus 1 terms. So number of terms from 1 to n minus 1 will be simply n minus 1, n by 2. So this 150, it must be greater than n into n minus 1 by 2, and it should be less than or equal to number of terms from 1 to n terms. So it will be less than n into n plus 1 by 2. Now basically n into n minus 1 should be less than 300, which should be less than or equal to n into n plus 1. Now we know that 16 into 17, it is 272. We need two consecutive terms, and 17 into 18, it is 306. So that means value of n, it must be 17, and that's your option A. Now the question is, in the sequence 1, 2, 2, 4, 4, 4, 4, 8, 8 times, where n consecutive terms have the value n, the 10,025th term is. Now if we look at this series, this is 1, this is 2, 2, this is 2 square, 2 square, 2 square, 2 square, 4 times. Then we have 2 cube, 2 cube, 8 times. Then it will be this series 2 to the power n minus 1, 2 to the power of n minus 1 times. Then we'll have this series of 2 to the power n times, and then we'll have series of 2 to the power n plus 1. Now suppose our 1025th term it lies in this series. Suppose 1025th term, it is in series of 2 to the power n. Now we need to find value of n. Now we know that number of terms from 1 to 2 to the power n minus 1 will be given by this GP 1 plus 2 plus 2 square up to 2 to the power of n minus 1. So it will be a into r to the power n minus 1 upon r minus 1. So it will be 2 to the power of n minus 1. Now 2 to the power n minus 1, it should be less than 1025 and it should be less than or equal to 2 to the power of n plus 1 minus 1, or 2 to the power n, it should be less than 1026 and it should be less than 2 to the power of n plus 1. Now we know that 2 to the power 10 is 1024 and 2 to the power 11 is 2048. So the value of n for which this inequality holds is 10. So our 1025th term will be simply 2 to the power 10, and that's your option B. Now here the question is number of terms common between the series. Now we are given this series which is 1 plus 2 plus 4 plus 8 up to 100 terms, and 1 plus 4 plus 7 plus 10 up to 100 terms. Now first series it is a GP and the second series it is an AP. Now if we write general term of this GP, it will be 2 to the power of n minus 1 and it should be equal to general term of this AP, which is 1 plus m minus 1 into d. So it will be this 3m minus 2. Now we can write this m as 2 to the power of n minus 1 plus 2 whole divided by 3, and this m, it is less than or equal to 100, because it is pretty obvious that last term of an AP will be much less than last term of GP. So we can write 2 to the power of n minus 1 will be less than or equal to 298. Now we know that 2 to the power 8 is 256 and 2 to the power 9 is 512. So that means this n minus 1, it should be less than 9, or the value of n, it should be less than 10. So the highest value of n is 10. Now we need to find values of n, for which we'll get a value of m which is an integer. Now if we take n as 1, we'll get m as 1. So one possibility is when the value of n is 1, 2 plus 2, 4, not allowed. Then another possibility when the value of n is 3. So this is 4 plus 2, 6. Then 8 plus 2, 10. 16 plus 2, 18. 18 by 3. So it will be n equals 5. Next one will be n equals 7 and n equals 9. So altogether there will be 5 values. So the number of terms common between the two series is 5, and that's your option C. Now here the question is 10th common term between the series is. So we are given 2 APs, 3, 7, 11 and 1, 6, 11. Now we know that terms common to both the series, they'll also be an AP with common difference equals LCM of common difference of the two series. Here common difference is 4 and here common difference is 5. So the common difference of this resulting AP will be LCM of 4 and 5, and that will be simply 20. Now first term which is common to both the series is 11. We need to find 10th term of the series. So 10th common term to this series will be a plus 9 into 20, 180 plus 11, and there will be 191, and that's your option A. Now here the question is, if A1, A2, A3 they are in AP, A2, A3, A4 they are in GP, and A3, A4 and A5 they are in HP, then A1, A3 and A5 are in. Now what we'll do is we'll start from here. We know that A2, A3 and A4 they are in GP. So what we'll do is we'll choose them as A3 by R, A3 and A3R. Now it says A1, A2 and A3 they are in AP, whereas A3, A4 and A5 they are in HP. Now if they are in AP, then 2 times A3 by R, it is equal to A1 plus A3. So we'll get A1 as A3 into 2 by R minus 1, or it is A3 into 2 minus R upon R, and this is our first result. And from the condition of HP we can write 2 upon A3R, it is equal to 1 upon A3 plus 1 upon A5. So we can write 1 upon A5 will be equal to 1 upon A3, 2 upon R minus 1, and will be 2 minus R upon A3R, or basically A5 is equal to A3R upon 2 minus R, and that's our second result. Now it says A1, A3 and A5 they are in what? So we need to find A1, A3 and A5. Now A1 actually is A3 2 minus R upon R, then we have A3, and A5 is A3R upon 2 minus R. Now if we multiply them, we'll get A3 square. So basically these three numbers they are in GP, and that's your option B. Now the question is, if A, A1, A2, A3, A2n minus 1B are in AP, A, B1, B2, B3, B2n minus 1, B are in GP, and A, C1, C2, C3, C2n minus 1B they are in HP, where A, B are positive, then the equation ANX square plus BNX plus CN equals to 0 has its roots which of the following is correct. Now if you look at this first series, which is A, A1, A2, A, 2n minus 1 and B, we know that this AP has odd number of terms. So its middle term, it will be equal to arithmetic mean of terms equidistant from the beginning and end. So we can write A plus B by 2, and it will be equal to its middle term. Now total number of terms in this series is, so total number of terms in this series is 2n plus 1, and middle term will be n plus 1 term. Now this actually starts from 0, so its middle term will be an. So from here we can write an equals a plus b by 2. Now we are given that a, b1, b2, b2n minus 1, b, they are in GP. If they are in GP, then their middle term bn will be equal to the geometric means of terms equidistant from beginning and end. So bn is equals to under root ab, and the same way a, c1, c2, c2n minus 1 into b, they are in HP, then their middle term cn will be 2ab upon a plus b. Now we know that an, bn, cn they themselves are in GP. So basically we'll have Bn square equals An into Cn. Now if we look at this equation, its discriminant will be Bn square minus 4 ANCn, and ANCn is Bn square, so it will be minus 3 Bn square, which is less than 0. That means roots of this equation are imaginary, and that's your option C. Now the question is, in an AP, as P is Q and as Q is P, then we need to find as P plus Q. Now as P is P by 2, 2A plus P minus 1 into D, and this is equal to Q, and SQ is Q by 2, 2A plus Q minus 1D, and it is equal to P. Now what we'll do is we'll subtract second from first. Now we can write P minus Q into A plus P square minus P minus Q square minus QD, and then we also have this 1 by 2, so it will be this whole divided by 2, and it will be equal to Q minus P. Now this is P minus QA. We can rewrite this as P square minus Q square minus P minus Q D by 2, and it is equal to Q minus P. Now we can cancel P minus Q, so we can write A plus, this is P plus Q minus 1 into D by 2, and this is minus 1, or we can write 2A plus P plus Q minus 1 into D, it is equal to minus 2, and that's our first result. Now it says we need to find sum of P plus Q terms. Now this is P plus Q by 2 and 2A plus P plus Q minus 1 into D. Now we know that 2A plus P plus Q minus 1D is nothing but minus 2. So this sum will be nothing but minus P plus Q, and that's your option B. Now here the question is, let A1 equals 0 and A1, A2, A3, An be real numbers such that mod of AI equals mod of I minus 1 plus 1 for all I, then arithmetic mean of these numbers has a value A, where which of the following is or are true. Now we square these, we can write AI square will be equal to AI minus 1 square plus 1 plus 2 AI minus 1, or we can write AI square minus AI minus 1 square, it is equal to 1 plus 2 AI minus 1. Now for this A, what we'll need is, we'll need A1 plus A2 up to AN. So what we'll do is we'll start from AN plus 1 square minus AN square, and it will be equal to 1 plus 2AN. Then we can write AN square minus AN minus 1 square will be 1 plus 2 AN minus 1, and we'll continue till A2 square minus A1 square, and it will be equal to 1 plus 2 A1. Now if we add these, all these successive terms, they'll cancel, and we know that A1 is 0, so this value will be 0. So from here we can write A square n plus 1, it will be 1 plus 1 plus 1 n times. So there will be simply n plus 2 times A1 plus A2 up to AN, and we know that square of any number is simply greater than or equal to 0. Now if we divide everything with n, we can write 1 plus 2 into A1 plus A2 plus AN by n, that is greater than or equal to 0. this is nothing but arithmetic mean of these values a. So we'll get 1 plus 2a is greater than or equal to 0, or a is simply greater than or equal to minus 1 by 2, and that's your option C. Now here the question is, if a, b, c are three positive numbers and a, b, c square has the greatest value 1 by 64, then which of the following is or are correct? Now we know that for positive numbers a, b and c, we can write a plus b plus c square by 3. It is always greater than or equal to abc square to the power 1 by 3, or abc square will always be less than or equal to a plus b plus c square by 3 whole cube. Now this is the greatest value. Now it says its greatest value is 1 by 64. Now if this is the greatest value, we'll have this condition that am must be equal to gm, and am is equal to gm if all the numbers are equal. That means a equals b equals c square. So what we'll do is we'll put a as c square and b as c square. So we'll get c to the power 6. It is equal to 1 by 64. Value of c is 1 by 2, and value of a and b, they are 1 by 4 each. And that means this option B is correct. Now the question is, we need to simplify this summation, which is r varies from 1 to n summation r square minus summation m varies from 1 to n summation r varies from 1 to m summation r. Now first we simplify the summation r. We can write summation r varies from 1 to n r square minus, and this is summation m varies from 1 to n, and this is m plus 1 by 2. So basically this is summation r varies from 1 to n r square minus, and it is 1 by 2 summation m varies from 1 to n m square minus 1 by 2 summation m varies from 1 to n summation m. Now limit of summation goes to 1 to n, then this variable, it doesn't matter. So what we'll do is, rather than taking it as m, we'll write it as r. So we can write simply summation r varies from 1 to n r square minus 1 by 2 summation r square, r varies from 1 to n minus 1 by 2 summation r varies from 1 to n. Now this is 1 by 2 r square. So we can write this as 1 by 2, and then it'll be simply summation r square, r varies from 1 to n minus summation r varies from 1 to n, and that's your option C. Now the question is, sum of product of 10 numbers taking 2 at a time is. So we have these 10 numbers, 1 plus 2 plus 3 plus 5, and then minus 1 minus 2 up to minus 5, and what we'll do is we'll take their whole square. Now it'll be 1 square plus 2 square plus 3 square up to plus 5 square plus again 1 square 2 square up to 5 square. So it'll be this 2 times 1 square plus 2 square up to 5 square, and then it will be plus 2 times sum of products of these 10 numbers taken 2 at a time. So it will be this summation ai into aj, where say I is less than j, and this is the required sum. So we need to find this sum and say this sum is s. Now left hand side is 0, and this is 2 times, and this is n plus 1, 2n plus 1 whole divided by 6 plus 2s. Now this 2 will cancel, this 6 will also cancel, So value of S is simply minus 55, and that's your option B. Now here we have two questions. The first question is, we are given that summation R varies from 1 to infinite 1 upon 2r minus 1 whole square, it is equal to pi square by 8. Then we need to find sum of this series. R varies from 1 to infinite 1 upon r square. Now basically, if we put r as 1, this is sum of odd terms. So it is 1 upon 1 square, 1 upon 3 square plus 1 upon 5 square, and we are given that it is equal to pi square by 8. And we need to find sum of the series, which is 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square up to infinite. Now what we'll do is, we'll separate even and odd terms. So we can write this series as 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, and then it will be 1 upon 2 square plus 1 upon 4 square plus 1 upon 6 square up to infinite. Now sum of this series, it is already given in the question, pi square by 8. So this sum, it is pi square by 8, and plus here we'll take 1 upon 2 square common. So we'll take 1 by 4 common, and then we'll have 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square up to infinite. And this is nothing but, this is simply S. So it is S equals pi square by 8 plus S by 4, or we can write 3S by 4 equals pi square by 8, or value of this S is pi square by 6. So value of this sum, 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square up to infinite, it is pi square by 6. That is one of the very famous problem known as the Basel problem, and we have already made a video on how to prove 1 upon 1 square plus 1 upon 2 square is equal to pi square by 6. Now we are given the second question. In the second question, we are given that 1 upon 1 to the power 4 plus 1 upon 2 to the power 4, 1 upon 3 to the power 4 up to infinite, it is pi to the power 4 upon 90. We need to find sum of odd terms. Now here also we'll separate odd terms and even terms. Now suppose this series is S. We can write this S as 1 upon 1 to the power 4 plus 1 upon 3 to the power 4 plus 1 upon 2 to the power 4, 1 upon 4 to the power 4, and this is equal to pi to the power 4 upon 90. Now this is the required sum that we need. Suppose this is S dash, and here we'll take 1 by 16 common, and here will be 1 upon 1 to the power 4 plus 1 upon 2 to the power 4 up to infinite, and is pi to the power 4 upon 90. Now this is the given series, so this value, it is pi to the power 4 upon 90. So we can write S dash plus pi to the power 4 upon 90 into 1 by 16, it is equal to pi to the power 4 upon 90, or S dash is 15 by 16 pi to the power 4 upon 90. Now this is 6 times. So this S dash will be pi to the power 4, and this is pi to the power 4 upon 96. So sum of this odd series is pi to the power 4 upon 96, and that's your option A. Now in this question, we are given this function fn, and this fn, it is 1 by 2 plus n by 100, where the square box, it represents greatest integer function of x. We need to find this value. Now we know that if n lies between 1 and 49, then 1 by 2 plus n by 100, it is less than 1. In that case, value of fn will be 0, and if n lies between 50 and 100, then 1 by 2 plus n by 100, it will be greater than or equal to 1, but less than 3 by 2. So in that case, value of fn will be equal to 1. Now if we look at this required summation, it will be this summation n varies from 1 to 100 fn. Now we can break this summation as n varies from 1 to 49 fn plus summation n varies from 50 to 100 fn. Now from 1 to 49, this is 0, and from 50 to 100, it is 1. So it is nothing but this summation n varies from 50 to 100, 1, and this is nothing but 51, and that's your option B. Now the question is, sum of infinite terms of a decreasing GP is equal to greatest value of this function in this interval. Now we are given this function fx, which is x cube plus 3x minus 9 in the interval minus 2 to 3. Now if we look at f dash x will be 3x square plus 3, which is greater than 0. That means this fx, it is strictly increasing, and if a function is strictly increasing, then it will achieve its maximum value at the end of interval. So maximum value of this function, it will be simply f3. Now this is 27 plus 9 minus 9. So maximum value of this function in this interval is 27. Now it says sum of this infinite GP, it is 27, and difference between first two terms is f dash 0. That means a minus ar, it is equal to f dash 0. Now f dash 0 is simply 3. So a into 1 minus r, it is 3. Now the sum, it is a upon 1 minus r, it is 27. Now we need to find their common ratio. So what we'll do is we'll substitute the value of a. So a is 27 into 1 minus r. So it will be this 27, and 1 minus r square equals 3, or 1 minus r square equals 1 by 9, or 1 minus r equals plus or minus 1 by 3. If we take this minus sign, we'll get value of r which is greater than 1, then it will become an increasing GP. We need a decreasing GP, so we'll take plus sign. So value of r will be 1 minus 1 by 3, and will be simply 2 by 3, and that's your option C. Now the question is, ABC is a right angle triangle in which angle B is 90 and BC is A. So we have a right angle triangle ABC in which angle B is 90 and the side BC, it is equal to A. If n points L1, L2, Ln are taken on AB are such that AB is divided in n plus 1 equal parts. So we have taken n points on this line AB. So we have L1, L2, Ln, and the same way we have taken M1, M2 and Mn on AC such that L1, M1, L2, M2, Ln, Mn are line segment parallel to BC. So all these lines, they are parallel to BC. That means they'll also form this right angle triangle. Now suppose this length is C and this length is Now there are n points and this AB is divided into n plus 1 part. So basically AL1, it is C upon n plus 1. AL2 is 2C upon n plus 1. And ALR will be equal to RC upon n plus 1. In the same way, AM1 will be B upon n plus 1. Again, it is divided into n plus 1 parts. AM2 is 2B upon n plus 1. And AMR will be RB upon n plus 1. Now, if we look at this line, LR, MR, then we can write LR, MR square will be equal to AMR square minus ALR square. Now, AMR square, it will be R square B square upon n plus 1 square minus ALR square will be R square C square upon n plus 1 square. So we can write LR MR square, it will be B square minus C square upon n plus 1 whole square into R square. Now B square minus C square is nothing but A square. So this length LR into MR will be simply A upon n plus 1 into R. Now we need to find sum of all these lengths. So we need this summation where R varies from 1 to n LR MR. So it will be this A upon n plus 1 and then this summation R where R varies from 1 to n. So it will be this A n plus 1 and here will be n plus 1 by 2. Now n plus 1 by 2 will cancel. So sum of all these lengths will be equal to an by 2 and that's your option C. Now here the question is we need to find value of this summation. So we write its general term TR, it is 1 upon under root of A plus Rx plus under root of A plus R minus 1x. Now what we'll do is we'll rationalize it. So we can write under root of A plus Rx minus under root of A plus R minus 1x upon this is A plus B into A minus B. So there will be A square minus B square. So we can write A plus Rx minus A plus R minus 1x. Now A will cancel and Rx will also cancel. So it will be simply under root of A plus Rx minus under root of A plus R minus 1x upon x. Now we need to find this sum, which is summation R varies from 1 to n TR. Now we put R as 1, it will be under root of A plus x minus under root of A plus under root of A plus 2x minus under root of A plus x, and we'll continue up to under root of A plus nx minus under root of A plus n minus 1x, and we have this x for all the terms. Now all these successive terms, they'll cancel. So we'll have this sum as under root of A plus nx minus under root of A whole divided by x. So the correct option is this option B. Now it should be R here. R varies from 1 to n r to the power 4, it is equal to fn. That means 1 to the power 4 plus 2 to the power 4 plus 3 to the power 4 up to n to the power 4 is fn. We need to find this sum. Summation r varies from 1 to n 2r minus 1 to the power 4. So we need to find 1 to the power 4 plus 3 to the power 4 plus 5 to the power 4 to 2n minus 1 to the power 4. So what we'll do is, we'll start with f2n, and f2n will be 1 to the power 4 plus 2 to the power 4 plus 3 to the power 4 up to 2n to the power 4. Now here again we separate even and odd terms. So we write odd terms together, 1 to the power 4 plus 3 to the power 4 and plus we'll have 2 to the power 4 plus 4 to the power 4 up to 2n to the power 4. Now this is the required summation that we need. So we can write f2n and will be equal to this summation r varies from 1 to n 2r minus 1 to the power 4, and here we'll take 2 to the power 4 common, so it will be the 16, and then 1 to the power 4 plus 2 to the power 4 up to n to the power 4, which is nothing but fn. So this is fn. So from here we can say this summation r varies from 1 to n 2r minus 1 to the power 4 will be equal to f2n minus 16 fn for all n. So the correct option is this option A. In this question we are given two functions fx and gx, and it says then the constant term in f dash x into gx is equal to what? Now basically we are given fx equals 1 minus x to the power n plus 1 upon 1 minus x. This is nothing but sum of a GP. So this fx is 1 plus x square up to x to the power n, and since we'll require f dash x, we'll differentiate this. We'll get 1 plus 2x plus 3x square up to nx n minus 1, and then we also have this gx, which is 1 minus 2 upon x plus 3 upon x square up to minus 1 to the power n plus 1 upon xn. Now if we multiply f dash x and g dash x, and if we look at just their constant term, we'll get this constant term when 1 gets multiplied to this one. So it will be this 1 minus then 2x multiplied by minus 2 upon x. So it will be 2 square. So it will be 1 square minus 2 square plus 3 square minus 4 square, and then we do not have x to the power n here. So this n, it gets multiplied with the term before, and which is minus 1 to the power n minus 1 into n divided by x to the power n minus 1. So it will be up to minus 1 to the power n minus 1 into n square. So this is the constant term that we need. Now we need to find sum of this series. Now we have two cases. Case 1, when n is even. Now when n is even, we can write this as 1 square minus 2 square plus 3 square minus 4 square, and then it will be n minus 1 square minus n square. So we will have these pairs. Now if we use a square minus b square, a minus b will always be minus 1, and then we'll have 1 plus 2. It will be this minus 1, 3 plus 4, and then minus 1, n minus 1 plus n So it will be this minus 1 and then 1 plus 2 plus 3 up to n. So it will be this minus n into n plus 1 by 2. So if n is even, then this sum is minus n into n plus 1 by 2, which is your option C. Now, what if n is odd? So we have our second case when n is odd. Now, if n is odd, we need to find this series 1 square minus 2 square plus 3 square minus 4 square up to n minus 1 terms, and then plus last term, and last term it will be minus 1 to the power n minus 1. So it will be simply plus n square. Now here these terms from 1 to n minus 1, they'll form a pair, and basically n minus 1, it will be even, and we know sum of even. So this sum of even will be minus, and here in place of n we write n minus 1, so it will be minus n minus 1 into n by 2 plus n square. So it will be this 2n square minus n square plus n divided by 2. So it is n plus 1 by 2. So this sum will be n into n plus 1 by 2. When n is odd, that means this option B is also correct. So the correct options are B and C. Now here the question is, if ABC are in GP and APQ are in AP such that 2A, B plus P, C plus Q, they are in GP, then common difference of this AP is. Now if ABC are in GP, we know that B square equals AC and APQ are in AP. That means 2P equals Q plus A. And we are also given that 2A, B plus P and C plus Q, they are in GP. So that means B plus P square, it is equal to twice A into C plus Q. Now what we'll do is, we'll subtract first from third, then we can write P square plus 2BP and L be equal to AC plus 2AQ. Now AC is nothing but B square. We can make it a quadratic in B, so we can write B square minus 2BP, and then it will be minus P square plus 2AQ equals 0. Now from here we can write B as 2P plus minus under root of, now this is 4P square minus 4 and then minus P square plus 2AQ whole divided by 2. We'll cancel this 2. So we'll get this B as P plus minus, and here will be under root of 2P square, and then we'll have minus 2AQ. Now we know that 2P is Q plus A, so we'll multiply both sides with 2. We can write 2B equals 2P plus minus under root of 2 into 2P square minus 8AQ. Now 2P is Q plus A, so it will be 2B, and this is Q plus A plus minus under root of 2 Q plus A whole square minus 8AQ, or we can write 2B equals Q plus A plus minus, we'll take root 2 common, and then it will be A plus B whole square minus 4AB, and that will be A minus B whole square. There will be root 2 A minus Q. Now the question, A, P and Q, they are in AP. Now if the common difference of this AP is D, then basically Q minus A will be equal to 2D. So we can write 2B, and this is 2D plus 2A plus minus root 2, and this Q minus A will be plus minus 2D. So it won't make a difference. So we can cancel this 2. Then we'll get B minus A, it is equal to D 1 plus minus root 2, or this common difference will be B minus A upon 1 plus minus root 2. Now if we take plus sign, then we get B minus A upon root 2 plus 1. We'll multiply and divide with root 2 minus 1. So it will be B minus A into root 2 minus 1. And if we take minus sign, then we can write B minus A upon 1 minus root 2. We'll multiply it with 1 plus root 2 and then 1 plus root 2. Now this is minus 1. So we'll get A minus B into 1 plus root 2. So the correct options are B and D. Now here the question is, if H1, H2, H3, H2n plus 1 are in HP, then we need to find value of this sum, which is this summation I varies from 1 to 2n minus 1 to the power I hi plus h I plus 1 upon hi minus h I plus 1. Now what we'll do is we'll divide numerator and denominator with hi plus 1. So we can write this summation as summation I varies from 1 to 2n 1 upon hi plus 1 plus 1 upon hi, and we have minus 1 to the power I upon 1 upon h I plus 1 minus 1 upon hi. Now we know that if h1, h2, h3, hn are in HP, then 1 upon h1, 1 upon h2 and 1 upon h2n plus 1 will be an AP, and suppose its common difference is D. So in the denominator it is nothing but it is D. So we can write this sum as 1 by D, and then this summation I varies from 1 to 2n minus 1 to the power I 1 upon h I plus 1 plus 1 upon hi. Now we'll expand it. If we put I as 1, we get minus 1 upon h2 minus 1 upon h1, and then for I equals to it will be plus, so it will be 1 upon h3 plus 1 upon h2 and then minus 1 upon h4 minus 1 upon h3, and in the end we'll have plus 1 upon h2n plus 1 plus 1 upon h2n. Now h2 will cancel, h3 will cancel, all these successive terms they'll cancel. So we'll get the series as S equals 1 by D 1 upon h 2n plus 1 minus 1 upon h1. Now this is 2n plus 1th term of an AP. So it will be 1 by D 1 upon h1 plus 2nd minus 1 upon h1. Now H1 will cancel, D will also cancel. So this sum will be equal to 2n. So answer to this question is 2n, and that's your option C. Now here the question is, we are given this function f(x), which is 2 to the power x upon 2 to the power x plus root 2, and we need to find this summation. Summation r varies from 1 to 2n minus 1, 2 times f r by 2n. Now what we'll do is, we'll write f r by 2n, and there will be 2 to the power r by 2n upon 2 to the power r by 2n plus 2 to the power 1 by 2, and we'll also write f1 minus r by 2n, and there will be 2 to the power 1 minus r by 2n upon 2 to the power 1 minus r by 2n plus 2 to the power 1 by 2, which we can write as 2 upon 2 plus 2 to the power 1 by 2 into 2 to the power r by 2n. Now we'll cancel root 2, so we can write this as root 2 upon root 2 plus 2 to the power of r by 2n. Now if we add these two, we can write f r by 2n plus f 1 minus r by 2n. It will be equal to, and the numerator will have 2 to the power r by 2n plus root 2, and in the denominator also we will have 2 to the power r by 2n plus root 2. So this value, it is equal to 1. So we have established this relation that f r by 2n plus f 1 minus r by 2n, it must be equal to 1. Now if we look at this series will be f 1 by 2n plus f 2 by 2n up to f 2n minus 1 by 2n, and this is basically f 1 minus 1 upon 2n. And then we have this 2 here, so what we'll do is, we'll write the series again, but now we'll reverse it. So we'll write 1 minus 1 upon 2n. Next one will be f 1 minus 2 upon 2n, and in the end we'll have f 1 upon 2n. Now if we add all these pairs, value of each of the pair is 1. So how many pairs do we have? We have 2n minus 1 pairs. So value of this sum will be simply 2n minus 1. And that is the answer to this question. Now here the question is, let A1, A2, An be terms of GP whose common ratio is R, and let Sk denote sum of first k terms of the GP. Then value of this sum I is greater than equal to 1, less than j, that is less than equal to m, ai into aj. Now this is sum of product of terms taken 2 at a time. Taken 2 at a time. We have solved this question previously in part 1, and answer to this question was r upon r plus 1 sm minus 1 into sm. So we are not going to solve it again. So answer to this question is simply B. Now here we are given that consider a sequence of natural numbers S0, S1, S2 such that S0 is 3, S1 is 3, and Sn is 3 plus Sn minus 1 into Sn minus 2. Then which of the following is or are correct? Now if we look at this series, we know S0 is odd, S1 is odd. Now if we look at S2, S2 will be 3 plus 3 into 3. Now this is odd plus odd, so it will be even. So we'll have S2 and this S2 will be even. Now S3 is odd plus S1 into S2, so it will be odd into even, and odd into even is even, and odd plus even is odd. So we'll have S3 odd. Now S4 will be 3, which is odd, plus S2 into S3. So this is even into odd, which again is even, and plus odd. So this again is odd. So S4 will be odd. Now S5 will be odd plus odd into odd, and there will be even. So this is even. So we'll get even if and only if previous two terms they are odd. We'll have this series where S2 is even, S5 is even. So basically S 3n plus 2, it is even, and if it is a multiple of 3 or it is of the form 3n plus 1, then it will be an odd number. Now it is asking for S1545 and S1546. Now if we look at 1545, it is divisible by 3. So this is 3 into 5, 1, 5. So it's a multiple of 3. So it is of the form 3n. So this is odd. And 1546 will be 3 into 515 plus 1, which is of the form is 3n plus 1, which also is odd. So both these numbers, they are odd. That means the correct option is this option D. Now here the question is, if A, B, C are in HP, then the value of A cube B cube plus B cube C cube plus C cube A cube upon A square C square is equal to what? Now we know that if A, B, C are in HP, then 2 upon B, it is equal to 1 upon A plus 1 upon C. What we'll do is, we'll take cube both sides, then we can write 8 upon B cube, and it will be equal to 1 upon A cube plus 1 upon C cube plus 3AC, and then 1 upon A plus 1 upon C. Now 1 upon A plus 1 upon C is nothing but it is 2 upon B. So we can write 8 upon B cube, it is equal to 1 upon A cube plus C cube plus 6 ABC. Now what we'll do is, we'll take 6 ABC on the left hand side and we'll also add B cube both sides. So we can write 9B cube minus 6 ABC, it is equal to 1 upon A cube plus 1 upon B cube plus 1 upon C cube. Now if we simplify this, we'll get this as A B cube into C, and here will be this 9AC minus 6B square, it is equal to B cube C cube plus C cube A cube plus A cube B cube upon A cube B cube C cube. Now B cube will cancel, AC will also cancel, so we'll get this as A square C square. So from here we can write A cube B cube plus B cube C cube plus C cube A cube upon A square C square will be equal to 9AC minus 6B square, and that's your option A. Here the question is, in a HP, we are given that its pth term is Q into P plus Q and its qth term is P into P plus Q, then P and Q are roots of which quadratic equation? So we need to find a quadratic equation whose roots are P and Q. Now we know that if these are terms of HP, the reciprocal will be terms of an AP. So we can write A plus P minus 1 into D, it is equal to 1 upon Q P plus Q. And same way, A plus Q minus 1 into D for this corresponding AP will be 1 upon P plus Q. Now if we subtract second from first, we can write P minus Q into D, and here we'll take 1 upon P plus Q common, and then we'll have 1 upon Q minus 1 upon P, and will be P minus Q upon PQ P plus Q. Now P minus Q will cancel. Common difference of this AP will be 1 upon PQ P plus Q, and we can write its first term and will be 1 upon P plus Q minus Q minus 1 upon D, and D is PQ P plus Q. Now will be Q minus Q plus 1 upon PQ P plus Q. Now this Q and Q will cancel. So its first term will be 1 upon PQ P plus Q. I have not given you the options, but then all the options, they are of the form TPQ and TP plus Q. So what we'll do is, first we'll find TPQ for this corresponding AP, and there will be A plus PQ minus 1 into D. Now since A and D, they are equal, this 1 and 1 will cancel, so it will be this PQ into A, which is 1 upon PQ P plus Q. This PQ will cancel, so it will be 1 upon P plus Q. So corresponding term for this HP will be simply P plus Q, and for this AP, if we write TP plus Q, will be A plus P plus Q minus 1 into D. Now here also this one will cancel, so we get P plus Q into 1 upon PQ P plus Q. So this value, it is 1 upon PQ. So corresponding HP will have P plus Qth term as P into Q. Now this is sum of roots and this is product of roots. So this quadratic equation will be x square minus sum x. So it will be this TPQX plus product equals 0. So it will be this TP plus Q equals 0, and that is the answer to this question. Now the question is, for the series 21, 22, 23 up to k minus 1 and k, the AM and GM of first and last numbers exist in the given series. If k is a 3-digit number, then k can attain how many values? Now, if we look at their arithmetic mean will be 21 plus k divided by 2. And since this series is a series of natural numbers, this a, it must be a natural number, and will be a natural number if this k, it is an odd number. So this k, it is odd natural number. So its arithmetic mean will exist in this series if k is odd. So that's our first condition. Now if we write their geometric mean will be under root of 21 to k. Now this again should be a natural number, and it'll be a natural number if k is of the form 21 into a square, where a is a natural number, then its geometric mean will be 21 into a, which will lie in this series. So this k, which is 21 into a square, it must be an odd number and it should be of the form 21 into a square, and it is given that it's a 3-digit number. So it's a 3-digit odd number. Now we know that 21 into 9 is a 3-digit number. If a equals 1, it is not a 3-digit number. So we'll consider a equals 3. If we take a as 3, then this k will be 21 into 9. So this is 189, which is a 3-digit odd natural number. So this is one possibility. If we take a equals 5, we'll get k as 21 into 25, 525. This is also acceptable. And if we take a as 7, we'll get k as 21 into 49, and it will be 1029, which no longer is a 3-digit number. So there are only 2 values of a possible, and therefore we'll have only 2 values of k. So answer to this question is 2 values, and that's your option C. Now the question is, if x is greater than 0, then minimum value of x to the power 1000 plus x to the power 900 plus x to the power 90 plus x to the power 6 plus 1996 upon x is. Now we have the sum of positive numbers. Now if we look at powers of x, and if we add all these powers, it will be 1000 plus 900 plus 90 plus 6, so it will be 1996, and we have this 1996 here. So what we'll do is, we'll write x to the power 1000 plus x to the power 900 plus x to the power 90 plus x to the power 6 plus 1 by x plus 1 by x plus 1 by x. We want to write it separately 1996 times. Now when we multiply all these terms, the powers of x, they'll cancel, we'll get this as 1. So their product is constant. So if we need minimum value of sum and product is constant, then basically we have to use AM, GM. So we'll use AM is greater than or equal to GM inequality. Now its arithmetic mean will be x to the power 1000 plus x to the power 900 plus x to the power 90 plus x to the power 6 plus 1996 upon x whole divided by, now number of terms here is 2000, and it should be greater than or equal to their geometric mean. Now if we multiply all these terms, we get x to the power 1996 into 1 upon x to the power 1996, which is 1 to the power 1 upon 2000, so it will be 1. So value of this sum, x to the power 1000 plus x to the power 900 plus x to the power 90 plus x to the power 6 plus 1996 upon x will always be greater than or equal to 2000. So its minimum value will be 2000, and that's your option B. Now here the question is, we need to find sum of this infinite series, which is given by this summation r varies from 1 to infinite r cube plus r square plus 1 whole square upon r to the power 4 plus r square plus 1 into r plus 1. What we will do is, first we will simplify this general term, which is say tr. Now this tr will be r cube plus r to the power 4 plus 2r square plus 1 upon r to the power 4 plus r square plus 1 into r plus 1. Now in the numerator, we'll rearrange it a bit. So we can write r to the power 4 plus r square plus 1 and plus r cube plus r square will divide by r to the power 4 plus r square plus 1 into r plus 1. Now we'll spread this, so we can write TR. Here r to the power 4 r square plus 1 will cancel, so we get 1 upon r into r plus 1, and here r into r plus 1 will cancel, so we get r upon r to the power 4 plus r square plus 1. Now here we'll add r square and we'll subtract r square, and also we'll multiply and divide it with 2. So we can write this TR as 1 upon r minus 1 upon r plus 1 plus 1 by 2, 2r, and this is r square plus 1 whole square minus r square, a plus b, a minus b, so it will be r square plus r plus 1 into r square minus r plus 1. Now we can write this as 1 upon r minus 1 upon r plus 1 plus 1 by 2, and this is 1 upon r square minus r plus 1 minus 1 upon r square plus r plus 1. So that's a general term. Now it is telescopic summation. So we'll put the values of t. So T1 will 1 minus 1 by 2, and this is 1 by 2 will be 1 minus 1 by 3. For second term, we'll put r as 2, so it will be 1 by 2 minus 1 by 3 plus 1 by 2, and here will be 1 by 3 minus 1 by 7, and we'll continue. And since it is an infinite series, all these successive terms, they'll cancel. So sum of all the terms up to infinite will be given by simply 1 plus 1 by 2, which is 3 by 2. So answer to this summation is 3 by 2, and that's your option A.
So let us take up another problem in triple summation, and that is triple sum of 1 when I is greater than or equal to 0, j is greater than I, k is greater than j, and k is less than or equal to n. So I'll write it as summation. Now this value of k, it should be greater than j, so we'll start with j plus 1 and we'll go all the way up to n. Now value of j, it is greater than I, so we'll start with I plus 1, and the maximum value we'll have is j should be less than k, so here it will be n minus 1, and the minimum value of I will be 0, and its maximum value should be less than maximum value of j, and it should be n minus 2, and we need to find this triple sum of 1. Now if I'll find this summation 1, so I can write it as summation I varies from 0 to n minus 2, j varies from I plus 1 to n minus 1, and here it will be 1 plus 1 plus 1, so number of summation times, and there will be n minus j plus 1 plus 1, so that should be summation I varies from 0 to n minus 2, j varies from I plus 1 to n minus 1, and it should be n minus j. I can also express it as summation I varies from 0 to n minus 2, j varies from I plus 1 to n minus 1, and then I'll write it as n minus j c1, because I know nc1 is simply n. So if I'll put the value of j, I can write the series as summation I varies from 0 to n minus 2, and then if I'll put j as I plus 1, I'll get n minus I minus 1 C1, n minus I minus 2 C1, n minus I minus 3 C1, and we'll continue. So last value of j will be n minus 1. So there will be 1 C1. So before that I'll have 3 C1 plus 2 C1 and plus 1 C1. So that's my series. So what I'll do is I'll replace this 1 C1 because I know 1 C1 is simply 1. So I'll replace 1 C1 with 2 C2. So NCN is simply 1. So if I'll use the property n same and r differs by 1, so it'll be 3C2. Now 3C1 plus 3C2, there'll be 4C2. So in the same way, if I'll solve the series, then I'll write the series as summation, value of I varies from 0 to n minus 2. And here it will be, the last one should be n minus I minus 1 plus 1 and then C2. So minus 1 and plus 1 will cancel. I'll get the series as summation I varies from 0 to n minus 2, and that should be n minus I C2. Now I'll try and solve this series. Now for this series, I'll write it as, so if I'll put I as 0, I'll get it as n C2. Then for I as 1, n minus 1 C2, n minus 2 C2. And then finally, when I'll put I as n minus 2, I'll get it as 2 C2. So I'll write 4 C2 plus 3 C2 and plus 2 C2. Now again, NCN is 1. So I'll write 2 C2 as 3 C3 because for both of them, the value is 1. So if I'll use the property again here, n is same, r differs by 1. So then it'll be 4C3. Now 4C2 plus 4C3 will be 5C3. So if I'll continue in this fashion, then finally I'll get n plus 1 C3. So the answer to this triple summation is n plus 1 C3.
Now here the question is, if sine square a by 2 sine square b by 2 plus sine square c by 2, they are in HP, then which of the following is or are correct? Now, we know that sine square a by 2 will be s minus b, s minus c upon bc. Sine square b by 2 will be s minus c, s minus a upon ca, and sine square c by 2 will be s minus a, s minus b upon ab, and they are in HP. Now, if we take the reciprocal, it will become an AP. So we get BC upon S minus B, S minus C, CA upon S minus C, S minus A, AB upon S minus A, S minus B. They are an AP. Now what we'll do is, in first we'll multiply S minus A. So in the numerator we'll have S minus A. Here we'll multiply with S minus B. So it will be this S minus B, and here will be this S minus C. This is S minus C. Now S minus A, S minus B, S minus C is nothing but this is delta square area. So we can write S minus A BC upon delta square S minus B CA upon delta square and S minus C AB upon delta square. They are in AP. Now we know that if we multiply or divide, the constant will still remain in AP. So we'll cancel this S. That is, we are dividing with S and we are multiplying with delta square. So we'll cancel. Now this is SBC minus ABC, SCA minus BCA, and SAB minus ABC. They are in AP. Now we also know that if we add a fixed constant to all the terms, it will still remain in AP. So we'll add ABC to all the terms. So ABC will cancel, and we'll divide S also. So we get BC, CA and AB. They are in AP, and if we divide it with ABC, we'll get 1 upon A, 1 upon B, 1 upon C. They are in AP, that means ABC. They are in HP. So sides of this triangle ABC, they are in HP. That means this option B is correct. Now, if we look at options C and D, then we can write 2 times B, C plus A, assuming them to be AP, should be equal to AB plus C plus C, A plus B. So there will be 2BC plus 2AB, and this is AB plus CA plus CA plus BC. Now BC will cancel once, AB will cancel once, and we have 2AC. So from here we'll get 2CA equals BC plus AB, or 2 upon B equals 1 upon A plus 1 upon C. That means again ABC and HP. So this condition C, it is correct. So the correct options are B and C. Now here the question is, let Fn denote number of different ways in which the positive integer n can be expressed as the sum of 1s and 2s. That is, say for example, F4 equals 5. We can write 4 as either 2 plus 2 or 2 plus 1 plus 1 or 1 plus 2 plus 1 or 1 plus 1 plus 2 or 1 plus 1 plus 1 plus 1. And we have taken these three as a separate entity. So here order is also important. So this Fn, it counts all the ways of writing a number in terms of the sum of 1s and 2s taken their order. Now if we look at F1, F1 is 1, and if we look at F2, we can write 2 as either 2 or 1 plus 1. So value of F2, it must be 2. Now we'll find Fn, which is number of ways of writing n in terms of 1s and 2s. Now there are two possibilities. In the end, we can have 1, or in the end, we can have 2. If we have 1 in the end, then all it remains is in how many ways we can write n minus 1 in terms of 1s and 2s. So this Fn will be equal to n minus 1, or that means we need to add this last number is 2, and if last number is 2, that means we have to express n minus 2 as sum of 1s and 2s. So it will be nothing but it will be f n minus 2. So basically this function, it follows Fibonacci sequence. So if we write F3, F3 is 1 plus 2, 3. F4 is 3 plus 2, 5. F5 is 5 and 3, 8. And F6 is 8 plus 5, 13. So value of F6 is 13, and that's your option B. Now the next one is find the value of f of f6. So we need to find f of f6, and f of f6 is nothing but it is f13. So we have to keep generating this series. Now f7 will be 21, f8 it is 34, f9 it is 55, f10 89, f11 4, 144, F12, 144 plus 89, 233, and F13 will be 144 plus 233, and that will be 377. So value of F6 will be this option C. Now since we are adding previous two values, the value of Fn, it always increases. So it is an increasing function, and if it is an increasing function, that means this function is 1, 1. So this function is a 1, 1 function. But then if we look at the values, so we have pre-images for 1, 2 and 3, but we do not have pre-image for 4. So there are values which are missing from the range. So if this function is defined from n to n, then this function, it will be an into function. So this function is 1, 1 and into, and that's your option B. Now here the question is, if n is set of all natural numbers and r is set of all real numbers, then a function f defined from n to r is given by fn equals 4n plus under root of 4n square minus 1 upon under root of 2n minus 1 plus under root of 2n plus 1. Now what we'll do is, we can write this as 2n plus 1 plus 2n minus 1 plus under root of 2n plus 1, 2n minus 1 whole divided by 2n minus 1 plus under root of 2n plus 1. And if we take under root 2n plus 1 as A and under root 2n minus 1 as B, so we have taken let under root 2n plus 1 is A and under root 2n minus 1 is B, then basically this Fn, it is A square plus B square plus AB upon A plus B. What we'll do is, we'll multiply and divide it with A minus B. Now this is A minus B into A square plus B square plus AB. So it will be A cube minus B cube, and here it is A square minus B square. Now if we look at A square minus B square, it will be 2n plus 1 minus 2n minus 1. This 2n and 2n will cancel. So in the denominator, we'll have 2. So it will be simply A cube minus B cube by 2. So we can write this Fn as 1 by 2, and then it is 2n plus 1 to the power 3 by 2 minus 2n minus 1 to the power 3 by 2. Now we need to find greatest integer function of this summation divided by 40. So first we'll calculate this summation. So we'll find this summation r varies from 1 to 40 fr. So we'll find this summation r varies from 1 to 40 fr. So it will be this 1 by 2. If we put r as 1, we'll get this as 3 to the power 3 by 2 minus 1 to the power 3 by 2. If we put r as 2, we'll get 5 to the power 3 by 2 minus 3 to the power 3 by 2. And if we put r as 40, it will be 81 to the power 3 by 2 minus 79 to the power 3 by 2. Now these successive terms, they'll cancel. So we'll get this summation as 1 by 2. Now this is 81 to the power 3 by 2. Now this is 9 square. So it will be 9 cube. 9 cube is 729. So it will be 729 minus 1. So it will be 728 divided by 2. And it will be 364. Now we need to find greatest middle function of this summation r varies 1 to 40 fr upon 40. Its greatest integer value. So it will be 364 upon 40. So this is greatest integer function of 9.1. So this value will be equal to 9. So value of this series, it is equal to 9, and that is the answer to this question. We have amazing questions when it comes to cancellation of terms in summation, which is simply known as telescopic summation. But when it comes to cancellation in product, there are a very few questions, and this is one of such rare questions. And the question is, we are given this product of terms in which we have 1 to the power 4 plus 1 by 4 into 3 to the power 4 plus 1 by 4 up to 2n minus 1 to the power 4 plus 1 by 4 upon 2 to the power 4 plus 1 by 4 into 4 to the power 4 plus 1 by 4 up to 2n to the power 4 plus 1 by 4. So basically we have odd numbers in the numerator and even numbers in the denominator. Now it says this series, it simplifies to 1 upon an square plus bn plus c. We need to find the value of a minus b plus c. In order to solve this question, what we'll do is we'll simplify one of the terms and let the term be tr, and it will be r to the power 4 plus 1 by 4, which we can write as r square whole square plus 1 by 2 square. Now we'll make it a perfect square. In order to make it a perfect square, we'll add 2ab and we'll subtract 2ab. So we'll add r square and we'll subtract r square. So we can write this as r square plus 1 by 2 whole square minus r square, which again is a square minus b square. So we can write this as r square minus r plus 1 by 2 and r square plus r plus 1 by 2. Now what we'll also do is we'll add 1 by 4 and we'll subtract 1 by 4 in both the terms. Now this again is a square plus b square minus 2ab. So we can write this as r minus 1 by 2 whole square and plus this is 1 by 2 minus 1 by 4. So it will be simply 1 by 4 and here it will be a square plus b square plus 2ab. So that will be r plus 1 by 2 whole square plus 1 by 4 and this is your tr. Now we can also write this as tr equals, now this is r minus 1 and plus 1. So it will be r minus 1 whole square plus 1 by 4 into r plus 1 by 2 whole square plus 1 by 4. Now basically this series is, it is t1 upon t2 into t3 upon t4 up to t2n minus 1 upon t2n. So what we'll also do is we'll simplify this expression tr minus 1 upon tr. Now tr minus 1 will be, we'll replace r with r minus 1, so there will be r minus 2 plus 1 by 2 whole square plus 1 by 4 and here will be r minus 1 plus 1 by 2 whole square plus 1 by 4 whole divided by r minus 1 plus 1 by 2 whole square plus 1 by 4 into r plus 1 by 2 whole square plus 1 by 4. Now these two terms, they'll cancel. So This simplifies to r minus 2 plus 1 by 2 whole square plus 1 by 4 divided by r plus 1 by 2 whole square plus 1 by 4. Now we'll start putting the values of r. So we can write this t1 upon t2. For t1 upon t2, we'll put r as 2, and if we put r as 2, it'll be 1 by 2 square plus 1 by 4 upon, and here it'll be 2 plus 1 by 2 whole square plus 1 by 4 into, now for t3 upon t4, we'll put r as 4, and if we put r as 4, we'll get this as 2 plus 1 by 2 whole square plus 1 by 4 upon 4 plus 1 by 2 whole square plus 1 by 4. We'll write one more term, t5 upon t6. So if we put r as 6, we'll get 4 plus 1 by 2 square plus 1 by 4 upon 6 plus 1 by 2 square plus 1 by 4, and this series will continue and will continue up to 2n terms. So we'll put r as 2n. So here we'll get this as 2n minus 2 plus 1 by 2 whole square plus 1 by 4 upon 2n plus 1 by 2 whole square plus 1 by 4. Now these successive terms, they'll cancel. So in the end, we'll have this as 1 upon 2 square plus 1 by 4 upon 2n square plus 1 by 4 plus 2n plus 1 by 4. It will be simply 1 by 2 upon, and this is 4n square plus 2n plus 1 by 2, or 1 upon 8n square plus 4n plus 1. So product of the series, it is equal to 1 upon 8n square plus 4n plus 1. So basically we get a as 8, b as 4, and c as 1. So the value of a minus b plus c will be 8 minus 4 plus 1, which is 5, and that is the answer to this question. Now the question is, we are given the series Sn, which is this summation k varies from 1 to 4n minus 1 k plus 1 by 2 into k square. Now, if we write first few terms, we can write this Sn as, if we take k as 1, we get this as minus 1 square, and then if we take k as 2, it will be minus 2 square. For k equals 3, it will be plus 3 square, and for k equals 4, it will be this 4 square, and then if we take k as 5, again it will be 5 into 6, odd number, so it will be this minus 5 square. So essentially, this minus 1 to the power k plus 1 by 2, it will be minus 1 if k is of the form 4r plus 1 or 4r plus 2, and it will be plus 1 if k is 4r plus 3 and 4r. So that means if we make them a pair of 4, then first two terms they'll have minus sign, and next two terms they'll have plus sign. So we can write this as minus 6 square plus 7 square plus 8 square, and we'll continue. So we'll have total 4n terms. So we'll have n such groupings. Now what we'll do is, we'll take 1 and 3 together and 4 and 2 together. So we can write Sn. Now this is 3 square minus 1 square. So it'll be 3 minus 1, 2, and then 1 plus 3 plus 4 square minus 2 square. It'll be 4 minus 2, 2, and then 2 plus 4. In the same way, 7 square minus 5 square, 2 into 5 plus 7. This is 2 into 6 plus 8. It'll continue up to 2 into 4n. Now what we'll do is we can take 2 common. So it'll be this 1 plus 2 plus 3 plus 4 up to 4n, which is sum of first 4n terms. So it'll be equal to 2, and this is n plus 1 by 2. So this 2 and 2 will cancel. So this is 4n into 4n plus 1. So this Sn can take the value when we have two consecutive numbers such that one of them is a multiple of 4 and the other one leaves the remainder 1 when divided by 4. Now 1056, it is 11 into 6 into 4 into 4, which is 32 into 33, which satisfies this criteria. So this A, it is correct. Now what about 1088? 1088 is 16 into 4 into 17. Now this is 32 into 34, which is not possible. So option B is incorrect. Now option C is 1120, which is 16 into 7 into 10. So we'll take 4, and this is 4 into 7 to 5 into 2. So there is no possibility of making it of the form 4n, 4n plus 1. So C is incorrect and D is 1332. It'll be 4 into 3 into 3 into 37. Now this is 36 into 37, and 36 is a multiple of 4. So the correct options are A and D. Now here the question is, a pack contains n cards numbered from 1 to n. Two consecutive numbered cards are removed from the pack, and sum of the numbers on the remaining cards is 1, 2, 2, 4. The smaller of the number on the removed card is k, then k minus 20 is what? Now from this deck of n cards, we have removed two consecutive cards, and the small number is k, so the cards will be k and k plus 1. Now sum of remaining cards will be 1 plus 2 up to n minus 2k plus 1. Now this is n plus 1 by 2 minus 2k plus 1, and it is 1, 2, 2, 4. We can write n square plus n minus 4k minus 2, and will be 2, 4, 4, 8. We'll take this 2 here, so it will be 2, 4, 5, 0. So we can write 4k equals n square plus n minus 2, 4, 5, 0. Now 2, 4, 5, 0 divided by 50 is 49. So we can write this as 4k n square plus 50n minus 49n minus 2450, or 4k equals n plus 50 into n minus 49. Now we have to find smallest value of k. So we have to find the smallest positive value of n for which this number, it is a multiple of 4. Now this n, it should be clearly greater than 49. Now the first smallest value is 50. So if we put n as 50, we'll get this is 100 and 100, which is 4 into 25. So that means value of k is 25. Now we need to find the value of k minus 20. So k minus 20 is 5. And that is the answer to this question. Now here the question is, let A, B, C be positive numbers such that B upon A is an integer, and if A, B, C are in GP, then arithmetic mean of A, B, C is B plus 2, then the value of A square plus A minus 14 upon A plus 1 is. Now, rather than taking them as A, B and C, what we'll say is, suppose the numbers are A, AR and AR square, and clearly R is an integer. Now it says arithmetic mean of these three numbers. So that means A plus AR plus AR square by 3, and it is equal to B plus 2. So it will be equal to AR plus 2. So we can write AR square minus 2AR plus A minus 6 equals 0. Now basically we'll get R as 2A plus minus under root of 4A square minus 4A A minus 6 upon 2A. Now this 2 will cancel. So we can write this R as A plus minus root 6A upon A, or basically this R is 1 plus minus root 6 by A. Now A is a positive integer, and this R, it should also be a positive integer. So we'll take this plus sign. So this R will be 1 plus under root 6 by A. Now we have to find an integral value of A for which 6 by A, it is a perfect square. So the only value of A possible here is 6. So we'll get A as 6 and R as 2. Now we need to find this value, A square plus A minus 14 upon A plus 1. So if we put A as 6, we'll get 36 plus 6, 42. 42 minus 14, 28. 28 by 7, which is 4. So answer to this question is 4.